In this video, we're going to take a look at a variety of types of combustion reactions. So let's start out with the combustion of metals. So if you take any metal and you react it with oxygen, so combustion is reacting in the presence of oxygen, then you're going to create a metal oxide. So essentially what's happening here is we're getting a redox reaction happening. We are oxidizing the metal, so we're gaining oxygen for the metal or we're losing electrons, and we're reducing the oxygens. We're losing oxygen or we're gaining electrons. So it is a type of redox reaction. Let's take a look at how that works then. So if we take, for example, magnesium metal and we react it with oxygen, then we're going to produce magnesium oxide. Okay, and if we balance that, we need a 2 in front of our magnesium. So we could split this up into our half reactions if we're taking a look at this from a redox perspective. So magnesium is being oxidized into magnesium 2 plus and 2 electrons, and then oxygen is being reduced. So we're gaining electrons to form two O2 minus ions. So type of redox reaction. Now, if you took this metal oxide and you react that with water, we would create a base. So in this case, we'd create magnesium hydroxide. So worthwhile to know. Now, nonmetals are also oxidized when combusted in oxygen. So if we take a nonmetal and we react it with oxygen, we're going to create a nonmetal oxide. So let's take, for example, sulfur, and we react that with oxygen. We're going to create sulfur dioxide. This one's interesting. This has environmental implications. We could take SO2, and we can further combust that, and that would produce SO3. Now, the reason I'm bringing this up as an example with environmental kind of aspects is because if we take a nonmetal oxide and we react that with water, we create an acid. So if we take this SO3 and react that with water, we actually create sulfuric acid. And this is how acid rain is actually produced. So kind of an interesting environmental connection here. Now, when we get to the combustion of organic compounds, it gets a little bit more complicated because they can undergo complete or incomplete combustion. So let's first look at complete combustion. Now, alkanes are considered to be hydrocarbons. So they're made up of carbon and hydrogen only. And alkanes are the simplest. These are found in things like fossil fuels, crude oil, and natural gas. Alkanes are commonly used as fuels because they release large amounts of energy in combustion reactions. You can also get combustion with alcohols. So something like ethanol is very useful as a biofuel. And so we can look at both of these kinds of combustion reactions. Now, for example, let's take octane, so C8H18. That's a liquid state. We can find that actually in our combustion enthalpy data tables. So kind of cool to know where to find that. We can react that with oxygen, and that's going to produce CO2 and water. Now, water, the state, kind of dependent. So it's going to be a gas at high temperatures, and it's going to be a liquid at low temperatures. So it kind of depends on how the combustion is happening, which state we're going to get. When we write out any combustion reaction, we always want to balance it. Good idea is to start by balancing the carbons. So I'm going to put an 8 here. Then we'll balance the hydrogens. We'll put a 9 here. And then we have 16 and 9. We have 25 O's. So we'd need a 25 over 2 here to make that balance. But we don't like fractions, so we're just going to multiply everything by 2. And that's the quickest way to balance combustion reaction with an organic compound. Now, the reason I picked this one, octane, is because this is the gas we stick in our cars. You could find the combustion enthalpy value in a data table, and you can see how quite large the value is. If we take a look at another example, our ethanol is C2H5OH. This, like I said, is used as a biofuel. And it's also going to produce CO2 and water. We'll just put that in the liquid state here. And again, when we're balancing, we're just going to start with the carbons, then the hydrogens. Now make sure you add this hydrogen with these ones here. So we have 6, which means we need 3 here. And then when you're counting the oxygens, don't forget to count this one here in the alcohol too. So we've got 4 and 3, so we need 7. Minus 1 is 6, so we put a 3 here. Okay, so that's how we balance those. Now, ethanol is, like I said, it can be used as a biofuel. Any of these, like alkanes or alcohols, you're going to be able to find in the combustion data tables if you need the different states or the formulas. So that's kind of nice. Now, the other type of combustion that can happen is incomplete combustion of organic compounds. So you end up with kind of a mixture of different reactions and different products that are being formed here. So if you have incomplete combustion with your alkane, let's just underline those there. With oxygen, you can either create carbon monoxide and water or carbon and water. And that's going to depend on the oxygen. So typically in a combustion reaction, oxygen's in excess, but and the limiting reactant is the fuel. But in incomplete combustion, oxygen becomes limiting. So this is our limiting reactant here, and the fuel is in excess. Now, the reason why these reactions are not so great is because carbon monoxide is poisonous. It binds irreversibly to our hemoglobin. And then the other products, carbon, that's basically soot that's produced. So it's that black stuff that's produced from a combustion reaction. All of these reactions can occur simultaneously with complete combustion reactions, but in different ratios. And one other thing to note is incomplete combustion is less exothermic than the corresponding complete combustion reactions. So we get less energy from these incomplete combustions. Now, if we took, for example, methane, react that with oxygen, essentially what we're doing when we're creating the reactions is we're just going to write out both. So we would create carbon monoxide, gas, and water. And then the other one, we would have methane and oxygen to make carbon and water. And then you would just balance each one for its respective things. So for in the first one, we got 1 carbon, 1 carbon. We need a 2 here. And then we have 2 and 3. So we'd need a 3/2. Again, not leaving fractions, so just multiplying everything by 2. Okay, so that would be our first balanced equation. And then the second one, carbons are balanced. We need another 2 here, and then we would have a 2 here. Okay, so that's how you come up with your combustion reactions for metals, nonmetals, as well as the complete and incomplete combustion of organic compounds. So that's it for this video. We'll see you in the next one.